science.
What did you think about Elon Musk's idea about nuking the poles of Mars in order to make it warmer?
Yeah, so some of these are kind of pie in the sky ideas,
Right.
But let's get to what he's trying to get at.
Yeah.
What you want to do is you want to introduce warmth. You want to block the ozone. You want to block the ultraviolet so that you can protect organic life. All right. So we have an ozone layer. It's the 3 oxygen atoms, O3, and ozone likes ultraviolet light. So ultraviolet light comes from the sun and gets eaten by ozone. Gets eaten. And when you do that, the ultraviolet light doesn't make it to Earth's surface. So even though they say, oh, wear sunscreen and sunblock 45, yes, that's for the 1% of the ultraviolet that gets through the atmosphere. If you're above the atmosphere, you are fried. So because ultraviolet is highly hostile to organic molecules and what we're made of as life. So you want to protect, you want to give life a chance. So you want to not only heat Mars, you want to find a way to block the ultraviolet light coming from the sun. So you need some mechanism, if not ozone, or just live underground, for example. Okay? And so I don't think we should think of the idea as a literal thing, but just it's a general principle of what you want to accomplish on Mars in doing so. So you want to warm it, you want to protect what could be the future of biochemistry, and then you seed it, and then you wait. You don't want to wait too long. You want to sort of speed it up if you could, and then you terraform Mars. SpaceX has. I visited him a couple of times. He's got a mug you can buy there. Then it has Mars on it. Okay, and then you put hot liquid in it, and Mars turns to an arable blue-green marble.
That's hilarious.
So yeah, it's very good. And it doesn't tell you that when you say, oh, I got a Mars mug, you know, and you show it off, and oh my gosh, when did that happen? It's an Earth mug, but it doesn't look like Earth.
There's a lot of people that go on
also, we think there's a lot of water that was once on Mars, which is a certainty, and we think it's just sitting below in a permafrost. So you wouldn't have to bring water to Mars. By the way, in the really distant future, you can just redirect a comet and get all the water you need. But
how far distant is that?
The comet's everywhere, dude. We're in a shooting gallery.
Yeah, that's not what I asked.
Oh,
how far away do you think it is before we could redirect?
How far away in time?
Yes.
Okay, sorry. We know how to do it, but there's no real incentive. So there's no funded engineering plan to do it, but we know how to do it on paper.
We know how to do it in a conceivable way?
Oh, yeah. So first of all, it happens with or without us because we are in the shooting path of countless thousands of asteroids and comets. Right. So what you would do is you'd find one that's headed close to us anyway in the 7th orbit down the line or the 100th orbit down the line. And then you'd slightly deflect it in such a way that it would then collide with Mars or even Earth if you wanted, if Earth needed some more fresh water.
Yeah, I heard that there's a possibility.
But the problem is if something really big that would fill lakes worth, if that collided with Earth, that would just be bad for life on Earth because it's a spontaneous deposit of energy that can change the climate and do. So you want to do that on a planet that you're trying to terraform.
Isn't that the speculation of how water got here in the first place?
So the jury's still out on that. There are tags in the oceans, in the water molecule, that tell you that the water must have come from more than one source. So that's what's confusing things. We want it to be a simple thing. It all came by comets, or it all came from inside the Earth through volcanoes. Volcanoes emit lakes and historically lakes and oceans worth of water just out of their calderas. So the problem is, as we say in science, overdetermined. There's plenty of comets to have delivered all the water. There's plenty of water that could have come out of volcanoes to give us all the water. So, but in the oceans, it's clearly a mixture, and so the final word is still out on that.